The F-47 Phoenix represents a highly confidential yet strategically significant project within the United States Air Force's broader modernization efforts. Though many technical aspects remain classified, the program has been steadily progressing behind the scenes as part of the Next Generation Air Dominance (NGAD) initiative, a priority effort aimed at ensuring the U.S. maintains decisive air superiority in the face of evolving and increasingly capable adversaries. The confirmation of the authenticity of the F-47 Phoenix unit patch by U.S. Air Force sources signals that this program is not conceptual, it is real, active, and shaping the future of air combat strategy. While much speculation surrounds the name Phoenix, it is important to understand that in U.S. defense culture, such names are often assigned to programs that signify strategic transformation, regeneration, or technological leapfrogging. In this context, the F-47 likely represents a leap from traditional fifth-generation fighter paradigms into the realm of sixth-generation capabilities. This is not merely a new aircraft, but a new way of conducting air warfare, centered on integration, speed, survivability, and control of the battlespace in the most contested environments imaginable. The F-47 is designed to operate in future combat theaters characterized by denied airspace, electronic warfare saturation, hypersonic threats, and fast-moving, multi-domain conflict zones. As a result, every element of its design, from its propulsion system to its command and control capabilities, is being engineered to maximize survivability and lethality in the most complex scenarios. At the heart of the F-47's role is the concept of manned-unmanned teaming. This approach allows the F-47 pilot to command a distributed set of collaborative combat aircraft, CCAs, which are unmanned, AI-enhanced platforms that can perform a variety of tasks. These may include suppressing enemy air defenses, acting as sensors or electronic warfare assets, or simply confusing enemy radars and drawing fire away from the manned element. These CCAs do not operate independently of the F-47, they are part of its mission system, extending its reach, increasing its survivability, and dramatically expanding its operational flexibility. The F-47 itself is expected to feature a blend of capabilities that go beyond traditional stealth and speed. Its design will likely include advanced active and passive sensors, highly secure communications, self-healing networks, and onboard data processing systems capable of synthesizing complex inputs in real time. Instead of relying solely on command centers or satellites, the F-47 is intended to function as an autonomous decision-maker within a broader combat network. A defining aspect of the F-47 development process is its reliance on digital engineering. This means that virtual prototypes and advanced simulations are used extensively in lieu of traditional physical testing early in the development cycle. This digital-first approach allows engineers to detect integration issues earlier, iterate designs more quickly, and ensure that the final product is more adaptable to future upgrades. Unlike the slow development cycles of previous aircraft, which often resulted in platforms being technologically outdated upon arrival, the F-47 is being designed with modularity and upgradability at its core. Additionally, propulsion systems under consideration for the F-47 involve adaptive cycle engines, revolutionary power plants that can shift between different operational modes depending on mission needs. For example, the engine could prioritize thrust and acceleration during a dogfight, then shift to fuel efficiency and range for extended patrols or deep strike missions. This kind of flexibility is essential for operating in vast theaters of operation without relying on vulnerable refueling assets. Another key advantage expected from the F-47 is its integration with data fusion and artificial intelligence. The jet will likely be equipped with decision support tools that provide the pilot with prioritized threat information, friendly unit locations, and targeting options. In highly contested environments where milliseconds matter, this human-machine teaming can allow for superior reaction time and decision-making compared to adversaries using more traditional platforms. While there is limited official imagery or technical data in the public domain, defense analysts and sources close to the program have noted that prototype test articles already exist and are being evaluated under secure and highly restricted conditions. These test platforms allow engineers and pilots to explore new configurations, weapons integration options, and performance envelopes without full public disclosure. The level of secrecy surrounding the F-47 is consistent with how previous stealth aircraft like the F-117 and B-2 were handled before their public reveal. Funding for the NGAD program, and by extension the F-47, has been consistent and significant. Unlike some previous programs that struggled due to cost overruns or unclear strategic vision, the F-47's development has been carefully planned and kept on track through focused goals, clear threat assessments, and multi-year defense planning documents. The Air Force has publicly committed to fielding this aircraft in the early 2030s, though elements of it, such as CCAs, or next-gen engines, may enter service sooner in other forms or platforms. The F-47 will not replace any single aircraft. Instead, it will fulfill a role that has become increasingly difficult for older platforms to perform. While the F-22 remains the world's most capable air superiority fighter, its production line is closed, its upgrade path is limited by 1990s era architecture, and it lacks some of the open systems modularity that future warfare will demand. The F-35, while highly versatile and widely adopted, is optimized for multi-role missions and international interoperability, not necessarily pure air dominance in pure conflict scenarios. The F-47 is being designed specifically to counter the highest-end threats with a purpose-built architecture for air superiority. In the larger strategic picture, the F-47 is not just about defeating rival fighters in the air. It is about enabling the U.S. military to achieve air dominance as a foundational condition for success in other domains. Control of the air enables freedom of movement for ground and naval forces, intelligence gathering across theaters, and the ability to strike high-value targets at will. In conflicts where advanced air defenses, sophisticated enemy aircraft, and contested electronic environments are expected, the F-47 will be a critical enabler of U.S. joint force operations. There is also a logistical and industrial dimension to this program. NGAD, including the F-47, is part of an effort to restructure the way combat aircraft are developed, procured, and maintained. The Air Force aims to move away from one airframe for 30 years thinking and instead toward a model that allows for quicker development of smaller production batches, followed by continuous modernization. The F-47 is seen as the first test case for this shift, combining advanced technology with a more agile acquisition model that allows the U.S. to keep pace with technological advances without waiting for decades-long redesign cycles. The F-47 Phoenix is not just a fighter jet, it is the embodiment of a new philosophy in combat aviation. It blends cutting-edge technology with strategic foresight, emphasizing flexibility, survivability, and networked warfare. Though the exact specifications and capabilities remain under wraps, what is clear is that this platform is central to the future of American airpower. It is a project shaped by the needs of modern warfare, driven by innovation, and focused on maintaining U.S. superiority well into the 21st century. Every signal from official sources points to its real-world development and eventual deployment, marking a new era in how the U.S. prepares to fight and win in the skies.